Today, this here is overboard motor 350. We have one of 350. We have 250, 150. But this one is a 350. So 36 volts. Uh, it is a motor overboard. So but I have already rewind it. I've already rewind it. So because it is a three-phase brushless motor. So but I already rewind it as a generator. I've already rewind this as a generator. So just wasting much time. I have to test it. So it is free. So now this is my 60-watt bulb. This is my 50 watts uh, bulb. Right. See? Let's see. So now this is my meter. It is reading from DC. So let me shift it to AC. So it is now on AC volts. So when you're doing any work, this is when you're dealing with AC, you have to put it on AC, because if you put it at DC, it will, this is electronics, so it will make it to malfunction. It will be having a memory issue. It will not be reading accurately. So depending on the what you want to use, if you want to read DC, put it on DC. If you want to read AC, make sure that it is on the AC. And the one you want to read a higher voltage, it is very, very safer for you to leave it at 700, because this meter can read maximum 700 volt AC, maximum. So now let me press it. Let me connect my meter. Let me squeeze the wire. Okay. So normally this overboard, usually when you spin it with hand, usually maybe 7 8 volts, but this one I've already rewind it. So it will give me higher voltage but low current. But when you haven't rewind it, it will give you low voltage but higher current. So you can see the output of the from the overboard. I've already connected on the meter. You can see the output. I've already connected on the meter. So now let me spin it with hand. Let me know the amount, how many volts it will give me. Let me know how many volts it will give me. Okay. So now, okay, let me spin. Okay, let's see. The higher you spin it, the higher the voltage. 50 volts. Wow, 60. Oh, 72 volts. Seventy-four. I got up to 74 volts with hand spinning. With hand spinning, I got up to 74 volts AC. So you can imagine that with spinning with shafts got up to 10 volts. Spinning with hand I got up to 10 volts. So it has been modified so it will give higher voltage less current. But when it hasn't modified, it came with three phase. You can use diode to convert it to single phase. It can give you higher current, less voltage. For this one, it can give you higher voltage, less current. So it is vice versa. It is vice versa. Let me spin it again. Let me know if I can get more than 74 volts. Okay, I got up to 80 volts. Wow. Got up to 70, 80, 80 volts. Wow. So now you can see the maximum I got with hand spinning it with my hand. Okay, so let me connect this 60 watts bulb. Okay, so I have to separate the wire to avoid short circuit. Though when you short circuit, there will not be any much effect, but this thing will drag. There will be a drag. So let me run it. I see. Let me connect because there is a bit drag. You can see, but a little bit hard to rotate. Can light up bulb. Okay, so now let me short circuit it. So when you short circuit, it'll be very hard to rotate. See, very hard. So that's like short circuit. Okay, now I have to run the test with this bulb. So now let me do the test by connecting this 50 watt LED bulb. So let's see the performance also with it. So wow, there is a more visible result than this. Wow. So here we have seen the results. The hoverboard is modified. So and with the modification, I can be able to raise the voltage and the current goes down a bit. Not that it goes totally down, because if it goes totally down, you can't be able to light up the bulb and light this one. So you know, voltage without current can't do any job. Even if it managed to do, it will be invisible. So higher voltage, less current. So I have used it to write up. So that is it today experiment. We show that I can modify hoverboard to give me higher voltage and less current. So one or two, there's something to learn with this experiment. Anything is achievable. Anything is achievable. So